Organic chemistry is essentially the study of carbon compounds. A very important category of the organic compounds are the hydrocarbons. From the name itself, we see that these are the compounds of hydrogen and carbon. So this is a very important category of organic compounds. These are the compounds containing hydrogen and carbon. Hydrocarbons are classified as saturated hydrocarbons. That is, these are the compounds containing all single bonds. And the unsaturated hydrocarbons, the compounds which have a presence of a double or a triple bond. So hydrocarbons are classified as saturated, that is the compounds that contain only single bonds, and unsaturated compounds which have a presence of either a double bond or a triple bond. In an organic compound, the name of the compound is derived by the number of carbon atoms it has. So the presence of one carbon atom shows that it is a meth compound. How we get the exact name, we'll see later. But one carbon compound means meth, 2 means eth, 3 means prop, 4 is but, and from 5 onwards it becomes easy. As you must have seen in maths from polygons, etc. The presence of 5 carbon atoms means pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So this is the number of carbon atoms present in the organic compound, and this is how it shows the name of the compound. Let's start with the saturated hydrocarbons. We know saturated hydrocarbons are those which have only single bonds. Let's start with alkanes. These are the hydrocarbons that contain all single bonds. Now let's take N is equal to 1. That is when only one carbon atom is present. So there is only one carbon atom. Now to satisfy the octet rule, it forms 4 covalent bonds. And since we are talking of hydrocarbons, it's linked to hydrogen. So this is an alkane, that is a saturated hydrocarbon linked to the hydrogen atoms by a single bond. And this is the compound formed when N is equal to 1. That is, this is an alkane containing one carbon atom. Now let's see what happens when there are 2 carbon atoms. We are still talking of alkanes. That means the 2 carbon atoms are linked to each other by a single covalent bond. Since each carbon atom has to satisfy the octet rule, so it forms 4 covalent bonds, that is 1, 2, 3 and 4. This also forms 4 covalent bonds. The 3 with hydrogen, since we are talking of hydrocarbons, and 1 with carbon. Similarly, these 3 spaces are occupied by hydrogen. Now let's take N is equal to 3. That is, there are 3 carbon atoms linked to each other by single covalent bonds. The other spaces are occupied by hydrogen atoms. These are the 3 alkenes that we get. So when N is equal to 1, we have only one carbon atom linked to 4 hydrogen atoms. So we get the formula CH4. That is 1 carbon, 4 hydrogen atoms. Similarly, when N is equal to 2, 2 carbon atoms are linked to each other by a single covalent bond, and the remaining spaces are occupied by 6 hydrogen atoms. So when N is equal to 2, the formula is C2H6. Similarly, for N is equal to 3, we get C3H8. Now, do you observe any trend in this? Let's observe. When N is equal to 1, we have 1 carbon atom. When N is equal to 2, we get 2 carbon atoms. Similarly, for N is equal to 3, we get 3 carbon atoms. In the first case, when carbon is 1, hydrogen is 4. That is, if we double 1, we get 1 into 2. So 2 plus 2, we get 4. In the second case, double 2, so we get 2 into 2, 4, plus 2, we get 6. Similarly, if we double 3, we get 3 2s are 6, plus 2, 8. And so it goes on. So the general formula of the alkanes is CnH2n plus 2, where N shows the number of carbon atoms. So when N is equal to 1, if we substitute in the formula, we get C1H1 into 2 plus 2, that is CH4. For N is equal to 2, we get C2H6 and so on. So when N is equal to 6, if we substitute it in the formula, we get Cn, that is C6H2n plus 2. That is 2 into 6 plus 2, which becomes 12 plus 2, 14. So for N is equal to 6, we get C6H14. So the general formula of the alkenes is CnH2n plus 2. Now we know that the number of carbon atoms gives the name to the organic compounds. So when number of carbon atom is 1, in this case it's 1. So 1 carbon atom means it's a meth compound, and since it is an alkane, we give the suffix -ane. So 1 carbon atom means meth, and since it is an alkane, it becomes methane. Similarly, 2 carbon atoms, it is eth, and since it is an alkane, it becomes ethane. Similarly, the names of the alkenes are derived in this manner. Say we take C5H12, there are 5 carbon atoms, so we see 5 means pent, so we get pent, and the suffix is -ane since it is an alkane, so the name becomes pentane. Now, what is the name of an alkane which contains 8 carbon atoms? From the table, we know 8 means oct. So the name of the alkane is written as the number of carbon atoms. So 8 carbon atoms means it is oct, and since it is an alkane, it gets the suffix -ane. So an alkane containing 8 carbon atoms is named octane. What is the formula of butane? Butane is a compound, that is, it is an alkane containing 4 carbon atoms. The general formula of all alkanes is CnH2n plus 2. So from the name butane, we know it contains 4 carbon atoms and it is an alkane. So we use the general formula of alkane. We substitute N is equal to 4. So we get C4H4 into 2 plus 2. That is, we get C4H, 4 to the 8, 9, 10. So the general formula of butane is C4H10. We talked of saturated hydrocarbons, that is the hydrocarbons containing all single bonds. Now the unsaturated hydrocarbons are those which have a presence of either a double bond or a triple bond. So when there is one double bond, those hydrocarbons are known as alkenes. And when there is a triple bond, those hydrocarbons are known as alkynes. Let's take alkenes. So alkenes are the hydrocarbons which contain one double bond. So in this case, there is one double bond being formed, and to satisfy the octet, it has to form 2 other covalent bonds. Since we are talking of hydrocarbons, all these spaces are to be occupied by hydrogen atoms. So hydrogen occupies this space and this space. Can it occupy this space? No, it cannot, because we know that hydrogen can form only a single bond. Hydrogen cannot form a double bond. So in this case, when N is equal to 1, it does not form a valid alkene. So for N is equal to 1, we have no alkene. Let's take N is equal to 2. So there are 2 carbon atoms since N is equal to 2, and the 2 are linked to each other by a double bond since we are talking of alkenes. Now let's satisfy the other places. Each carbon can now form only 2 more covalent bonds, 1, 2, 3 and 4. and these places are taken up by hydrogen atoms. So we get H. So this is an alkene containing 2 carbon atoms. Let's take alkene containing 3 carbon atoms. Since now we have 3 carbon atoms and there is a presence of 1 double bond, so the first carbon is linked to the other carbon atom by 1 double bond, and the other one is linked by a single covalent bond itself. Let's try to occupy the other spaces by hydrogen atoms. So this forms 1, 2, 3, 4. This carbon atom is already forming 3 covalent bonds, so only 1 covalent bond can now be formed, and this can form 3 more covalent bonds. And these positions are taken up by hydrogen atoms. So now these are the 3 alkenes that we get for n is equal to 1. We know we are not getting any alkene because hydrogen cannot form a double bond. So n is equal to 1 does not give us any alkene. For n is equal to 2, we get C2H4. For n is equal to 3, we get C3H6. Do you observe any trend in this case? Yes, you do. You see, when n is equal to 2, there are 2 carbon atoms and there is double the number of hydrogen atoms. Similarly, for n is equal to 3, there are 3 carbon atoms and double the number of hydrogen atoms. So the general formula of the alkenes is CnH2n. That is, if the number of carbon atoms is n, the number of hydrogen atoms is twice the number of carbon atoms. So we know n is equal to 1 does not give us an alkene. So for any other alkene, say when n is equal to 4, if we substitute it in the formula, we get C4H2 into 4, that is 8. So when n is equal to 4, the alkene is C4H8. Now let's try to name the alkenes. Again, we know the number of carbon atoms gives the names. So let's start with the valid alkene, that is C2H4. So 2 carbon atoms means it is eth, and since it is an alkene, it gets the suffix -ene. So it becomes ethene. Similarly, say we have C5H10. So 5 carbon atoms means it is pent, and since it is an alkene, it gets the suffix -ene. So it becomes pentene. So this is how the alkenes get their names. What is the formula of an alkene with 9 carbon atoms? So we know the general formula of the alkenes is CnH2n. So when there are 9 carbon atoms, if we substitute this n with 9, we get C9H18. So the formula of an alkene containing 9 carbon atoms is C9H18. What is the formula of hexene? So as you can see, hex shows the presence of 6 carbon atoms. So now we know the general formula of alkenes is CnH2n. We're talking of hexene, that means there are 6 carbon atoms in the alkene. So we substitute this n with 6, we get 6 into 2, 12. So the formula of hexene becomes C6H12. We have talked of alkanes, that is the hydrocarbons linked to each other by single covalent bonds. Alkenes contain a double bond. Now let's talk of alkynes. These are also unsaturated hydrocarbons containing a triple bond. So for n is equal to 1, there is 1 triple bond and 1 single bond. So this space can be occupied by hydrogen. But can hydrogen form a triple bond? No, hydrogen forms only a single covalent bond. So hydrogen cannot take this place, and so n is equal to 1 is not a valid alkyne. Let's take n is equal to 2. The 2 carbon atoms are linked to each other by a triple bond. 1 space is only left, which is occupied by hydrogen atoms. Let's take n is equal to 3. So there are 3 carbon atoms. There is a presence of 1 triple bond. The remaining spaces are occupied by the hydrogen atoms. Keep in mind, each carbon atom forms 4 covalent bonds. So now, if we look at the alkynes, what do we see? We see N is equal to 1 is not a valid alkyne because hydrogen cannot form 3 covalent bonds. N is equal to 2, we get C2H2, and for N is equal to 3, we get C3H4. Any trend in this case? Let's see. N is equal to 2, we get C2. If we double this number, we get 4. Minus 2, we get 2. Similarly, for C3H4, we have 3 carbon atoms. If we double 3, we get 6. And 6 minus 2, we get 4. So the general formula of the alkynes is CnH2n minus 2. We know N is equal to 1 is not a valid alkyne because carbon cannot be linked to hydrogen by forming 3 covalent bonds. The remaining alkynes follow the general rule, that is the formula CnH2n minus 2. So let's take N is equal to 3 in this case. So when we have N is equal to 3, we substitute it in the formula. We get C3H2n, that is 3 2s are 6 minus 2. So we get 6 minus 2, that is 4. So we get C3H4. Let's name the alkynes now. As we had done for alkenes and alkenes, say we take C4H6, the presence of 4 carbon atoms means it is but. And since it is an alkyne, it gets the suffix -ine. So it becomes butyne. Similarly for all the other alkynes. Now the formula of heptine. What is the formula of heptine? We know hept means there are 7 carbon atoms. The general formula of the alkynes is CnH2n minus 2. Since we are talking of heptine, we substitute N as 7. So we get C7H7 into 2 minus 2. So we get C7H12. So this is the formula of heptine. What is the name of an alkyne containing 8 carbon atoms? Now, we know when there are 8 carbon atoms, we have the name oct, and in this case, we are talking of an alkyne, so the name becomes oct, and the suffix becomes -ine. So this is the name of an alkyne containing 8 carbon atoms, that is octyne. So now let's revise the hydrocarbons. We've seen hydrocarbons are the compounds of hydrogen and carbon. They can be open chain or aliphatic, or they can be cyclic or closed chain compounds. Now when we talk of open chain or aliphatic hydrocarbons, we see that they can be saturated or unsaturated. Saturated, we have alkanes, that is the compounds of carbon linked to each other by only single covalent bonds. And the unsaturated hydrocarbons show the presence of a double or a triple bond. They can be alkenes, that is which contain a double bond, or alkynes, that is those compounds which contain a triple bond.